Hello everyone. In this module, we are going to be talking about what are the different ways of improving the performance. So let us say that after we create any application, so the next thing that we will be doing that is to deploy it to a machine. Okay, now every machine is having a limitation. For example, let's take that we have a machine which can support some 300 queries per second. All right. This means that if 300 concurrent requests are going to come, this machine is going to be able to handle them without having any issue. Now, initially, when we are having let us say when we are having only few customers, like let us say three customers, in that case, 300 concurrent requests are more than enough. However, if application is becoming popular and more than this, let us say now we are getting some 1,000 queries per second. So what will happen, like the system which was able to take care these many queries, 300 queries, now it is having a demand of 1,000 queries. So then we will have a problem. This is going to make the system fail if we are not going to address it properly. Now let us assume that you are working for a company. All right. Or let us say you are the owner of some application, because in both of the situation you are going to be taking care about all the problems which you are going to be facing with that system. So let us say now what is happening, your system is struggling to keep up with the load. So how you are going to be feeling? Are you going to feel good about it, or are you going to feel bad about it? Of course, you are going to be feeling good about it, because this is a good problem to have. This is a sign that your application is gaining popularity. That is the reason now we are having a load issue. So, for the startups and all, this is a dream scenario. So now what we should be doing? So in order to address such a problem, we have already discussed a solution, that is scaling. So we can go ahead and apply scaling there, right? So what we can do, we can deploy our we can go ahead and apply horizontal scaling here. And what we can do in such a situation, we can go ahead and deploy it over different machines. This approach we call as horizontal scaling. We have seen that for such a problem, horizontal scaling is the solution. But with this, now we will be having some new set of problems. What are those? So the first problem which we have is IP address management. So customers are actually going to be remembering the IP addresses of all the four machines, which is not at all easy. Even if I'm going to ask you, in the real life, if I'll give you four phone numbers, it's not possible for you to remember phone numbers of all the four people, right? Similarly, remembering the IP address of all the four machines is not easy. Second one is load imbalance. Because if all the customers, let us say they all pick up the same machine, so what will happen, that one machine will get overloaded, and handling the traffic, whatever the traffic we are going to get on that particular machine, that is going to lead to the performance issues, right? Now in order to address these problems, we came up with something which we go ahead and call as load balancing. So when we talk about load balancing, like what we do here? So when you talk about the customers, they only need to know about this one, load balancer. This is the only single point of contact for the customers. Now what happens, like, when you talk about load balancer here, what happens, we are like, for our different set of machines, we are going to be having a load balancer. And in this one, like, we are actually going to be running it on a separate machine, and that is actually going to be acting as a mediator between the client and the multiple backend machines. So if this is the client, and here we are actually having some set of machines. So instead of the client directly talking to them, they are going to be talking to the load balancer here. And from this, we are going to be interacting with the other set of machines. So here, your load balancer is actually going to be receiving all the incoming requests for the customers, and then it is going to be determining that which backend machine he should be forwarding that request to. And accordingly, when he will get the response, it is going to return it back. So this is the only purpose of the load balancer. What it will be doing, it is trying to be balancing the load. Okay. So with the load balancing, customers are only going to be needing to know the IP address of this load balancer. They do not need to know the IP addresses for remaining machines. Now, let's say we are having some web application. For that web application, we are actually going to be having three components. First, we are going to be having a front end. Then we are going to be having a back end. And then we are going to be having a data storage. These are going to be the different components, right? So what we can do, we can apply the same principle of distribution to each of these components. So what we are going to be doing in since we are going to be having traffic across the different platforms, right? So here we are going to be creating a, instead of having one database, what we will do, we are going to be having a distributed database. Even your backend is going to get divided across several machines. Similarly, your front end can also be distributed across different machines, right? So instead of having all of them at one, what we are going to do, we are going to be distributing them out. Now here, if let us say if you are talking about some of the distributed systems, so whether your resources are going to be located in a single place or if it is across multiple location, it often makes sense to add a load balancer so that we can effectively manage the traffic. A lot of times you are going to be seeing how load balancer is going to be coming into the picture in the distributed system. So here what we will do, let me just squeeze this inside. Yeah. So here we have a user. Now what we are going to do, we are going to have a load balancer before the front end. Then we will have a load balancer before the back end. Then we will have a load balancer before the data storage. So that is how we are going to be doing. We can actually use a load balancer anytime you are having multiple machines. In these situations, your load balancers are typically employed so that it can distribute the load and it can optimize the system performance. The load balancers can be used whenever there is going to be a need to distribute the traffic across multiple machines. Now now we are going to be discussing about how we can use horizontal scalability here. So let's consider that we have deployed our application on multiple instances. Let us say your instance 1, instance 2, instance 3, instance 4. So these are the 4 instances where we have deployed. Let's take one more instance, 5 as well, for the better understanding. Okay. So by doing this, what we are doing, we are making our application horizontally scalable. Now what we are doing, with multiple instances running, we have also made it highly available. It means if one of the instance goes down, it will still be like, the, like, let us say your instance one is going down, so the others are still going to be up and running. So what is actually going to happen here? This is going to make your system fault tolerant. Okay. However, there is a mistake which we need to address here. So if you talk about the load balancer, so if we will have a single load balancer in the system, what will happen? If load balancer is one single instance, so what does it mean? It means we are going to be having single point of failure. So this load balancer is going to be distributing the load, right? If load balancer goes down, the entire application can become unavailable, right? In order to solve this problem, we came up with a solution which we call as replicated load balancer. So what happens? We are going to be having one active load balancer and one passive load balancer. So what will happen if, like, let us say your active load balancer fails. If this one is not responding, in that case, your passive load balancer is going to take over. So what it will be doing, this is going to be ensuring the high availability. Okay. Now we are going to be discussing what type of load balancers we have. So we typically have two types of load balancer. One is at the hardware level. So your hardware load balancer. The other one is software load balancer. Now, when you talk about hardware load balancers, so these are the physical devices which we use so that we can distribute the traffic. Now, with the hardware load balancer, we have better performance, we have better security, but at the same time, these are going to be more expensive. And these are going to be less flexible. These are very rigid. Okay, on the other side, when you talk about software load balancer, so these are the software. So some solutions on some software level we are going to be running in order to balance the load. So these are going to be comparatively cheaper and they are going to be offering you the more flexibility. Okay, but they may not be offering the same level of performance. So here performance is also better. On the other side, for the software, the performance is going to be low. Now we are going to be talking about distributed load balancer. So what exactly happens? So when you talk about a complex system, so there we are going to be having thousands of machines. So in that case, your single load balancer is not going to be sufficient. So in that case, you should be using distributed load balancer. So here we are going to be having, like, we are going to be having different layers. So at every layer, we are going to be deploying multiple load balancers so that we can ensure redundancy and at the same time, we can balance the load across the large number of machines. So in this one, we are going to be having a layered structure where one load balancer is going to be managing the load of other load balancers. So basically, what exactly is going to be happening here? So we are going to be having a load balancer which is going to be taking care of the load of the other load balancers. All right, that is how it is going to be there. And here, what is going to be the best part, that if let us say this is you, so what we are doing, we are having a load balancer here. Now this load balancers are actually going to be taking care of the other load balancers. All right, and this one is going to be connected to several machines. So what is exactly happening here? If you will see, we are having distributed load balancer here. So if you will see exactly what is the benefit of achieving it in this way. So if any of the load balancer goes down, the other one is still going to be up, and that is going to be improving the system fault tolerance. So in such a situation, system is going to be less prone for the failure. Now what are the key responsibilities of a load balancer? So what a load balancer is going to be doing? So like I said, we have to remember the IP address, right? So what it will do, it is going to be knowing the IP address of all the backend machines. Okay. What is the next one? It is also going to be monitoring the health of each machine. So this is going to see that when you are sending a request, so it is not going to unhealthy servers, because if it will go to unhealthy servers, chances are that they may not receive the request back. The second one is track the load. So it is going to see which load, which machine is actually getting more load. And accordingly, it is going to be sending the request to the other machine. So basically, we are trying to make sure that not one machine is getting overloaded. Okay. The other one is measuring the response time. So we will see, when we are sending any request, at that time how much response time it is taking, and how it is helpful, so that if you have some priority task, if you have to some tasks are there which require some quicker response, so we can go ahead and prioritize them. Next one is considering the geographical distance. So what will happen? We will be having different machines, and we will have to see where all those machines are located, so that we can optimize the routing. Okay. Also, what it will be doing, it is going to be storing the information about the last client server side communication, so that it can ensure consistent routing. Okay. Now we are going to be taking one example, and with the help of that example, I am going to be explaining you session persistence and sticky load balancing. So let us assume that you work for Amazon. All right. Now let us say that we are having a cart service. And this cart service is actually running on 4 different machines. Your M1, M2, M3, M4. All right. Now let's assume that all the 4 machines are of same size, they have same response time, and they all are performing equally well. Now we have a load balancer in place, and we are using round robin algorithm. So what it will be doing, it is going to ensure that it is distributing the load evenly across all the machines. All right. Now let's consider a scenario that your load balancer is directing a request to the machine M1. Now, at that point, what you will do? You are adding two items to your cart. So what we have done, we have added some product 1 and product 2 to our cart. Now what will happen? Later, at later point of time, you want to show these products to your family. Let us say you want to discuss with your family, you want to take their approval before placing the order. However, when you are opening the cart again, then the load balancer is redirecting you to machine M3 because of the round robin algorithm. Since you have added the items on M1 and now you are accessing your cart through M3, you may not be able to see the products which you have added earlier. This problem came because the session information is not stored across all the machines. Your card data was not stored across all the machines. So there are the multiple ways to solve this problem, and we are going to be discussing all of that. Okay. So to address this problem, we are going to be using sticky load balancing. Okay. We also call it as session persistence. So here what happens, with sticky load balancing, the load balancer is going to remember that which machine handled the client's last request. So that will ensure that subsequent requests from the same client are routed to the same machine. This way, your card data is going to remain constant across all the requests. So this is going to be solving the problem of losing items in the cart. So you understood what it is doing, like as the name is suggesting, sticky. What it will do, if you are having different machines, it will remember that, okay, on machine M1, you maintain that cart. And what it will do, if you will have, if this customer is there and if it is making some another request, so it will direct it to the same machine. It will stick to the same machine. So that is how your sticky load balancing works. All right. Now, what we will do, we are going to be discussing the weighted load balancing. So when machines will have different configuration, they let us say all the machines are having different RAM or CPU power. In that case, if you are using round robin approach, so that is not going to be the ideal. In that case, you can use weighted load balancing. So what does it mean? Here you are going to be assigning weight to each machine based upon the load. All right. So here what we will be doing, machines which will be having high resources, like machines where, so here what we will be doing, those machines who are having more resources, more RAM, so we are going to be sending more requests to them. Whereas if we have certain machines where we have lower resources, so those ones are going to be handling few requests only. So let us say we have a machine M1 and that has 16 GB RAM. Okay. Next machine M2 that is having 8 GB RAM. Now what will happen, let's take one more machine M3 which is having 4 GB RAM. Now what will happen? The load balancer will have to send a request. So what it will be doing, it will be sending more traffic to the M1, less to M2 and comparatively least to the M3 according to their capacities. So that is how it is going to be working. Another optimization technique involves adjusting the load based upon the response time. Now assume that we have four machines, M1, M2, M3, M4. And let us say we know the performance of each of the machines. So let us say that M1 takes 5 seconds to respond. Your M2 takes 3 seconds. Your M3 take 2 seconds and your M4 take 16 or 12 seconds, anything. Okay. Now we know that the response time of all of the machine. So when a request is routed to M4, so the one which is taking the maximum time, in that case, the load balancer will try to avoid sending request to M4 again for some time because it knows the response time for that is 12 seconds. So it is not going to send for some time. The load balancer will avoid sending requests to M4 if it will take a lot of time to respond. And it will be prioritizing M1, M2, M3 because they are taking lesser time. So this ensures that the requester doesn't have to keep waiting for a response from the slow machine. So this is very useful for those systems where we actually require real-time performance. So many advanced load balancers not only balance the load, but they also consider the response time or performance of the machine. So based upon this data, the load balancer is going to decide which machine to route a request to. All right, everyone clear? Now, the next one which we have here is your circuit breaker problem. So, this is one of the modern feature of the load balancer. So, if a machine is consistently slow or down, so your load balancer will stop sending requests to that machine temporarily. In this, if this machine is consistently slow, like we know from a long time it is slow, or if it is down. So, what we will do? We will say that don't send a request to this machine. In this pattern, what happens? The load balancer waits for a threshold time. So during that time, it stops sending requests to that problematic machine. After a certain period, it will reattempt sending requests to the machine once it becomes healthy again. This approach helps us to prevent overloading a machine which is underperforming, and we also ensure a smoother performance throughout the system. When you talk about load balancer, so they play a crucial role in scaling a system. So when you scale your system so that it can handle more traffic, a load balancer is very important to ensure we have efficient traffic distribution, and at the same time we are maintaining system health. It improves your system performance and it tries to give the best user experience. All right. Now the next we are going to be seeing that how the load balancer is actually based upon load. So as a load balancer, you are also aware that which machines are under heavy load when we are performing computation. So when the load balancer detects a machine is overloaded, so it will avoid sending request to that machine for a period of time. Instead, what it will do, it will be routing requests to the other machines that has less load. So that way we can prevent the overloading machine from becoming a problem. So this is one of the advanced feature of the load balancer, that it can intelligently identify which machine is under the high load, and accordingly it can make decisions based upon the information which we have, so that we can optimize our system performance. So this one is actually closely linked to the response time. If a machine has a high response time, we say that this machine is under heavy load. This machine is processing more requests than it can handle, right? So by monitoring response time, the load balancer can predict which machine can be overloaded, and accordingly we can take our decision. All right. After this, we are going to be discussing caching, and we will also see how we can use caching here. Now we are going to be discussing caching. So when you talk about caching, so this can actually improve your application performance. Now how it is actually going to be doing. So when you talk about caching, so this is a very powerful technique, but it needs to be used correctly. You can take example of salt. So when you talk about cooking, so if you are going to be adding salt, so you should always be adding it in the right amount. If you are adding it in the right amount, it is going to be enhancing the flavor. But if you are going to add too much, it is going to ruin the dish. So similarly, when you talk about caching, so this can actually boost the performance, but only when we are using it correctly. If we are not using it properly, it can lead to a lot of disasters. So when you are going to do it right, you can improve the performance by 100%. I'll actually take one small example here, okay, so that you can understand it better. So let us say this is me, and I love eating sweets, and there is some sweets shop which is some 10 kilometers from my place. So if I want to eat sweets, I have to travel 30 minutes. Now let us say I'm extremely fond of sweets. So I will go in the morning to buy the sweets, I'll go in the afternoon, I'll go in the evening as well. So I'm every day I'm actually going there three times. So you can see 30 minutes to go and come back, 1 hour, 1 hour, 1 hour. So you can see I have actually spent my 3 hours only to get the sweets. So what happened? Like, one day I just got an idea that instead of getting it three times in a day, why don't I get it only once in a day? So what I started doing when I'm going in the morning, so at that time I'm getting sweets for the entire day. So this way, if you will see in 1 hour, I am able to get my things done. But I thought that, okay, this is an efficient way. Why can't I save more time? Why can't I make it more efficient? So what I did, I thought of buying weekly. So I thought that instead of spending 1 hour every day, so 7 hours in a week, why don't I reduce that time, and instead of getting every day, why don't I get it only like, in a week by only getting it only for 1 day? So what exactly is going to happen? I can save my 6 hours, right? This is what I thought. But here, what is happening in that case, your sweets are getting spoiled. So you can see this is what, if you are not dealing with caching correctly here. So here also I'm using the concept of caching here. So if you talk about these things here, I'm not able to do it properly. If I'm doing it less, I'm spending more time. If I'm doing it more, I am having chances of food getting spoiled. But if I am doing moderately, in that case, it is going to work fine. Similar thing happens even with the caching as well. So, you should not be overdoing it. You should not be doing it in a less form. So, I hope it must be clear to you, right? Now, we'll be discussing, whenever you have to implement caching, but in all things, you should always keep in your mind. So, when you talk about caching, right, you always need to keep one thing in your mind, that your cache, you should be doing cache of that data which does not change frequently. So, cache data that does not change frequently. Now, what does this mean? Like, let us say you are caching some piece of data, but if that data keeps moving, keeps updating, in that case, it's not at all worth it, right? Let's take the example of your Instagram feed. So, what happens the moment you are going to be opening it, you are going to see some of the posts. What will happen if you will open it after 2 minutes? You are going to see some different set of posts. So, that is the data which changes very rapidly, very frequently. So we cannot go ahead and cache that data. But what is that which you can cache? Let's talk about you are playing a movie. For that, the metadata, which is going to be related to that movie, where you are going to be having information like your title, genre, and all. So all of those data, that is something which is not going to get updated. So that is something which is wise for you to cache it, right? So this is something which you should always be avoiding. All right. Also, whenever you talk about caching, so you should always be doing it in a moderate way. All right. Now I'll be taking an example of movie booking system here. So here what is happening, if I talk about a movie metadata. where you have like the cast of the movie, the duration of the movie. If you talk about the like release date, if you talk about the genre. So if you talk about this metadata, so all of these things does not change frequently. So this data can be cached in the memory because retrieving it from the database every time a user searches for it can slow down because of the network latency. But for the same thing, if you talk about seats, so if you are booking your seats, so if you let us say you want to look at the available seats, so if you talk about the seat availability, you must have seen on the book my show application. So this is how you are going to be seeing, and they are going to be doing something like gray already booked. Then there will be something which is going to show that okay, these are the available seats. So this information is something which will change rapidly. So if you are going to be opening after 10 minutes, you may be seeing some different available seats. So do not cache this information, but this one is good to go. So this way, like you can see that if you are caching the available seat, so that is not improving the performance. But if you're caching the movie metadata, that is improving the cache, right? Now we are going to be looking into the cache update strategy. So when you talk about the cache update strategy, so one of the strategy which we use for updating our cache is called as your write through cache. All right. So in this strategy, you are going to be having a database for the application, right? Database for your application, what it requires? It requires some stable storage, correct? And we are also going to be using some cache which can store the frequently accessed data. Right? So whenever you will have to write some data, it will first go to the cache. All right. And then it will be written to the database. So first it will go to the cache and from there it will go to your DB. So this will ensure that your cache and database, they always remain synchronized. You are always having both of these things in sync with each other. All right. So you should always be like visualizing it like if this is you, if you have some data. So what you will be doing, and this is your data storage, which is having a stable storage. So if you want to write, you are always going to go to the cache first. So firstly, it will go to the cache. This is your step one. From cache, it will be going to your data storage. So this is how it will be going. And here we are going to be maintaining synchronization throughout. Okay. Now, what is the advantage of this approach? So, the first advantage of using this approach is firstly, the fresh data. So here, like, this cache is always going to have the fresh data. It means there is not going to be having any stale data since we are always getting it from the cache. So the chances of having stale data is not at all there, right? The second one is fast reads. Now, when you talk about fast read, so what is going to happen? Here, the read operations are going to be fast because they are actually coming from the cache. So it is going to be reducing the load on your database. So these are the advantages which we have. Now we will be quickly discussing what are the challenges which we face here. So the first challenge is risk of data loss. So if you talk about here, we are not like, if the data is not properly written to the stable storage, like let us say when it is in cache, there only it is getting lost. So we have the risk of data loss. The second one is limited cache size. So like, let us say that your database storage is actually storing a large amount of data. So like let us say here we have something like 500 GB storage. On the other side, when you talk about cache, like let us say this is only of 2 GB. Just example. Okay. So here if you will see, only data which can accommodate in 2 GB can only be stored here, right? Because it cannot store even if we have a data of 3 GB. So as a result, we can only store the frequently accessed items here. So that is actually going like, if you talk about the items which are of bigger size, so we are going to be retrieving it from the database, and that is going to result in the uneven performance. So sometimes it is going to be fast, sometimes it is going to be slow, because if you are getting it from cache, it will be fast. If you are getting it from the database, it is going to be slow. So overall, we are going to be having some uneven performance here. All right. The next one is slower writes. So when you talk about writing, here we are saying that we are going to be writing our data to both, first to the cache and then to the database. So because of that, your write operation is going to become slower. So this is a problem for your write intensive application when we are going to be only performing the write. Okay. Now we have already discussed how we are going to be performing in the write through cache. Okay. The next one which we have here is your read through cache. And we will be seeing how your read through cache is going to be working. Okay. So like, when you talk about the read through cache, so here what we will be doing here, your cache is going to be updated during the read operation and not during the write operation. All right. So here, what is exactly going to be there? So like, what the flow is exactly going to be there. Like, let us say this is you. And now you have a stable data storage here. And you are having some cache. So let us say you want to write in the database. So what exactly is going to do? You are going to be like, firstly, you are going to be writing it to the cache. Once you have written it to the cache, this cache is going to be writing it to your stable database. Then your database is going to be updating, like, what is exactly happening here. We are like, firstly, here we are performing our write operation. Okay. So when you perform the write operation, it will directly go to the database. So this is what we are doing here. Here your cache is not updated, right? Then the second one is a read operation. So when a read request is made, so that second one I'm talking about the read. So first, system is first of all going to go to the cache. There it is going to be checking if the data is available or not. If it is not available, it will go to the database. If it is finding, like, if they are able to find a data, then it is okay. If they are not able to find a data, like, data not found in cache. So that is what we go ahead and call as cache miss. So here if it is not available, what we will be doing, we are going to write it to our cache, and from cache it will be like, whenever we have to retrieve, we are going to be retrieving it from the cache. So here if you will see, your cache is going to get updated. So this is basically what we are going to be doing here. Now, what are the advantages of this approach? So the first advantage is fast write. Since here we are directly writing it to our database, so that is going to be a fast operation. The second one is data integrity. So here, since your data is not getting lost because we are writing directly to the database, so we can say your data is going to get maintained. And also, like, this is best when you have write intensive application. So when you are going to be having such applications where you have to perform write operations more, so this is going to be the best one. Now, what are the disadvantages of this approach? So the first disadvantage is slower initial performance. So what happened, like, when you are going to be starting any application, the response time is going to be slow because your cache is not at all built that time. We are going to be retrieving it from the database. So initially it is going to be slower. Also, like, initially your slow operations are going to be, read operations are going to be slow. All right. Also, here we have the risk of stale data. Since here there is always a chance that we are going to be, like, since we are reading it from the cache, there is a possibility that if that cache is not being updated correctly, so we can go ahead and read our stale data. So these are the disadvantages which we are going to be facing here. So that's all I had for this module. Now we are going to be meeting in the next one. Till then, happy learning. Bye bye.